Section 3.5, derivative of trig functions. We have y equals sine of x. Here's the graph of y equals sine of x. And we're going from negative 4 pi to 4 pi. So this is 4 pi out here on the ends. And there are 8 marks, so each mark is worth pi over 2. Now the slope of the tangent line at pi over 2 is 0. So if we were to graph this, if we were to plot this, the derivative, we'd have 0 right here at pi over 2. And then the slopes would be negative, so then the graph would go down, but then it would eventually get back to 0 right here. And then the slopes would go positive, and the graph would get back to 0 here. Well, that's exactly what cosine is doing along the graph. So y prime, the derivative of sine, is equal to the cosine of x. Now the relationship between cosine and sine is here, the derivative is negative sine of x. Revisiting the differentiation rules. Find the derivatives of y equals x squared sine of x. So let's do letter A. Y prime, the derivative is first times the derivative of the second function plus the second function times the derivative of the first function. So there's not a whole lot you can do with this one other than maybe reorder this one. So we have 2x sine of x. And then letter B, we have the quotient rule. So we have bottom times the derivative of the top, that's going to be times negative sine of x. And then so we have bottom times derivative of top minus top times the derivative of the bottom, and the derivative of sine is cosine, but we got this negative right here, so that's going to be times negative cosine of x. And that's all over the bottom squared, so we have 1 minus sine of x squared. And we can simplify this. We have, let's distribute the negative sign. We have negative sine of x, and then plus sine squared x, and then plus cosine squared x, and that's all over the denominator, 1 minus sine of x squared. But sine squared plus cosine squared is 1. Now we have 1 minus sine of x on top over 1 minus sine of x squared. And then this 1 minus sine x cancels out with one of those. So the final answer is 1 over 1 minus sine of x. Here we have jerk. A sudden change in acceleration is called a jerk. When a ride in a car or a bus is jerky, it is not that the accelerations involved are necessarily large, but that the changes in acceleration are abrupt. Jerk is what spills your soft drink. The derivative responsible for jerk is the third derivative of position. So the third derivative is titled jerk. It is like extreme acceleration, an extreme change in acceleration. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. And notice all of the cofunction, the derivative of the cofunctions, they're all negative. Even the derivative of cosine of x is negative sine of x. So all cofunction derivatives are negative. Example 4, find tangent and normal lines. Find equations for the lines that are tangent and normal to the graph of this function at x equals 2, support graphically. We're going to find the derivative by hand, and then we'll use our calculator to get the derivative. Let's find f prime of x, the derivative. We have bottom times derivative of the top minus the top times the derivative of the bottom, which is 1, and that's all over x squared, the bottom squared. We're going to evaluate this at x equals 2. Let's type in 2 times, and we need secant, so that is 1 divided by cosine of 2. But we need to square that denominator, so let's back up. Let's back up here, and let's put in a parenthesis here. And how about 1 here? And then we can square that denominator, and then we can close the fraction, and we will minus tangent of 2. That's the top of the fraction. We'll press enter. and then we can divide by 4, which is, of course, is x squared. So our slope is 3.433. So 3.433. Now we need to get the point. We have a point 2 comma something, and so we need to take the tangent of 2 and then divide that by 2. We have negative 1.093. So the equation of our tangent line is y plus 1.093 equals 3.433x, and then minus 2, like that. Now we want the normal line, so we have to take the reciprocal. Let's go up here. Let's get this value back in here, and we'll press enter, and then we'll take 1 divided by the answer. There's a reciprocal, and of course we want the negative of this. So the normal line is y plus 1.093 equals negative 0.291 times x minus 2. Now we're going to get this value right here, 3.433, using our calculator, and we can do that in math. We go to math, and if we arrow down to n deriv, let's see, this calculator is a little slow. There it is, number 8. So we can press 8 or enter. And here is, we're going to go with respect to x. Here's the function. It's tangent of x divided by x. And then this is your evaluation bar, right there, evaluation bar. And we're evaluating this at 2. So there's the 3.433. A trigonometric second derivative. Find the second derivative if y equals secant of x. So the first derivative equals secant of x tangent of x. But then when we do the second derivative, we have a product of two functions now. We have first times derivative of the second, and the derivative of tangent is secant squared, plus the second times the derivative of the first, and the derivative of secant is secant tangent. And we can simplify a little bit here. We could factor out a secant of x, and that would be secant squared plus tangent squared x. And then we have to check our Pythagorean identities to see if this is any identity that we might recognize. Well, I know that 1 plus tangent squared x is equal to secant squared x. And if we subtract this over, subtract this one, I know I could make secant squared minus tangent squared 1, but as it turns out, this is really not a Pythagorean identity.